Independent events, what does the word independent mean? You guys should know because none of you are. What does it mean? Singular. Why does the government consider you dependents? I consider you parasites. Parents might do the same. The government considers you dependents. Why is that? Because you're living off. You rely on your parents, correct? You are their dependent. Are your parents considered dependents? I would argue that not many of them feel like they depend on you, correct? So they're independent because they rely on themselves. They don't rely on anyone else, correct? So, independent events, that's where the word independent sort of is coming through despite my sledging. There is a reason behind this. Why have I introduced it like that? What am I trying to point out? Independent events don't? Yeah, they don't need each other, they don't rely on other events, correct? So when we're talking about probability, we're talking about events whose probability doesn't depend on each other, isn't affected by the other's probability, correct? For example, if I had a game where I flip a coin and roll a dice, does the rolling of the dice influence the flipping of the coin? Doesn't influence the effect, correct? So we would expect that flipping ahead and rolling are independent events, they don't rely on each other. So what's the probability of getting ahead given I roll a 6? So I've rolled a 6, what's the probability of getting ahead?
1 on 2.
1 on 2, correct? Which is what? What's that the probability of? Well, let's ask another question. Playing the same game, what's the probability of rolling a 6 given that I've got a head? I flipped the head, what's the probability of rolling a 6? 1 over 6. Okay. Probability of getting a head? Probability of getting a 6? So, in this equation, what I'm going to write? The probability of A, given I get B, is the probability of? The probability of getting ahead, given that I've rolled a 6, is simply the probability of getting ahead, correct? We'd expect that because they don't rely on each other. So this here is the formula we need. That only works for independent events, correct? And it makes sense. I just asked you what the probability of getting ahead, given that we've rolled a 6, and you told me it was half. How do you know it was half? Yeah, but how do you know that?
I've seen a coin.
You've seen a coin? So what you've done is you've inserted the probability of flipping ahead, because you know the events are unrelated, correct? That's our equation. Probability of A given B is equal to the probability of A. Because B doesn't affect A. Whatever that might be. So we learned this equation last lesson. Probability that A given B is equal to the probability of A intersecting B divided by the probability of B, correct? What can I do with that now? I'm dealing with the formula. Yep.
Isn't it just the same as probability of A?
So for an independent event, so I should write for independent, I can't spell independent, that's alright, event. We know that PR A given B equals PRA. So we can sub that in. PRA equals PR A and B divided by PRB. So what that tells us is if the events are independent, PRA and B is equal to PRA times PRB. So I'll just revisit some of this stuff so that we are aware of what we are doing. What are independent events? What are independent events? Events that are independent, they're not reliant upon each other, correct? So the probability of rolling a head and a 6 are examples of that, because flipping a head and rolling a 6, because the probability of one doesn't impact the probability of the other, correct? With that, we know that the probability, the conditional probability of A given B is simply equal to the probability of A. Why do we know that? Because they're independent, and we know that rolling a 6 has no impact on the probability of A. Rolling a 6 has no impact on the probability of flipping a coin. We use that information, so a newly found equation, with something that we already know. We knew this from last lesson. We already know that. We can now replace PRA given B with PRA, and now we've got a new equation. Either one of these works, doesn't matter which one, the one in the blue or the black. Why doesn't it matter which way? I can rearrange. Can everyone in the room rearrange those equations? So providing what they give us, we just want to make that the subject of the equation, correct? We sub that and we've now got a new equation which works for independent events. So if I gave you the probability of A intersecting B and the probability of B, can you find probability of A? If I gave you A and B, could you find the probability of A intersecting B? Providing the events are independent. Sweet? Now that's a lot of information. We need a chance to practice that, and we're going to get that now. Before I go any further, I want to ask you whether the following events are independent or not, so we can put a little test on that. I go down to the local casino and I play a game of roulette, and the first one comes up red. Does that impact the probability of the next event? So it's just as likely to be red on the next one as it is to be black? Okay, good. I'm playing a game of, what's the one where they say hit? Blackjack, that's the one. I'm playing blackjack. I'm at home with my mates, though I'm not doing this at the casino, I'm at home with my mates. We've got a deck of cards. I see a king get drawn for the person next to me. Does that impact the probability of the next card that gets drawn for me? So is that an independent event? Okay. I've got 2 jars with marbles. They've both got the same number of marbles. It's 5 green and 5 blue in each. If I pull out a green marble in the first jar, does that impact the probability of pulling out a green in the second? What about if I put all the marbles into one jar? Grab a green one out and then I go for the next one. Does that impact the probability?
Yes.
So you need to be really clear about what's an independent event and what's not an independent event. Once we know that, we can apply these formulas. Does that look easy when you first see it? Or does that look a bit weird? Because when I read a textbook, I don't get much sense out of that. But when I see this, that makes a lot of sense. When I'm putting an example with it, it makes a lot of sense. So if you ever get lost with this stuff, try and visualise what's actually going on, and that might clarify a few things. So we're going to do exercise 5.4, questions 3, 5 and 8. Get started.